Okay, here we go. So in this, I'm going to be doing a little bit of a demo for you guys. We're going to be going over VLAN configuration, configuration of our access ports and our trunk links. Also say like router on a stick. We're going to be looking at Etherchannel configuration and then also going over a bit of OSPF configuration. So this might be a little bit of a longer demo. I'm going to try and make some little time markers at certain intervals, or at least write them down so you guys can skip ahead if there are certain sections that you want to kind of look at. So we're going to start with going over kind of VLAN configurations and things to do. I'm going to demo it a couple times, and then for some of the devices, just so that you don't have to watch me do it over and over again, I'll just go a little, I'll pause it and just go over it and do it real fast. So let's get started. So starting off, here's just a topo that I've just created to just demo. We have a fair number of different networks that we're setting up, and we've got our 192.168.10.0/24 network on VLAN 10, 20.0 on VLAN 20, 30.0 on VLAN 30, 40 on 40, and then 50 is just up here. It's not on any given network, so, or I mean on any given VLAN. So we're just going to have that off on its own, but we'll use it for demonstration for OSPF. And we'll kind of look at a few other kind of configs here as well. Now, one thing to note really quickly with our configuration here is that our VLAN tags, or our VLANs themselves, they only matter within a given LAN, so up until the point they hit a layer 3 device. So essentially, if we look at, say, like our network here, VLANs and their tags for, say, this area, VLAN 10 and VLAN 20, that number only matters up until that router, our router 0, up off of G02, because the VLAN tag will not make it any further. So we need to remember that when traffic is sent out of a LAN going towards another network, when traffic passes up the switch, it's a full frame. So it has our layer 2 and our layer 3 header, and the layer 2 header has our source and destination MAC address. But once it enters into a layer 3 device, remember that layer 3 device, in order to figure out and route that traffic correctly, it has to de-encapsulate the packet back down to the layer 3 header, and then read the source and destination IP address, make a routing decision based off of the destination IP address, and then rebuilds the frame based off of the exit interface and the destination interface of the next LAN it's sending the traffic off to. And then it repeats until the device makes it. So it's a frame while it's in our LAN, it's a packet while it's inside the router, and then the router makes the forwarding decision, rebuilds the packet into a frame as before it is able to send traffic out of a specific interface. So to kind of visualize that a little bit better, I have a small little item here that can kind of help with that. So our image here, and I can increase it just a little bit, is essentially the structure of our frame itself. So again, when I'm talking about the frame being built and sent out from a device going out towards our network, before that frame can leave our PC, the layer 3 header, source and destination IP address, and layer 2 header, source and destination MAC address, have to be built and attached and created. Once that traffic gets sent out, the switch reads the destination MAC address, determines where it's bound for, and then moves it on and forward. Now, in terms of VLANs, we use a method of encapsulation that adds on a VLAN tag onto the layer 2 header. So when if say like our PC here on VLAN 10, PC 0 is trying to ping PC 1 over on VLAN 20, when that traffic is being sent out, traffic goes up to the switch looks at it, and it recognizes that FAO2 is a part of the VLAN 10 network. So any traffic going into or out of this interface is automatically associated with VLAN 10 based off of what it sees. So there's no VLAN tag added when the PC is sending the traffic out, because it doesn't know, and it doesn't need to know what VLAN it's associated with. So when it figures that out, it will then the switch will then look at it and go, right, this came from VLAN 10. Where is it supposed to be destined to? Oh, it wants to go to VLAN 20, PC 1 over here. Well, that's on a separate virtual LAN, so I can't send it that way. So it needs to be forwarded out towards a router. And for that, as it goes across a trunk link, say going across towards another switch or going directly up to the router itself, that is when a VLAN tag is added to the layer 2 header. And only then, when it's going across trunk links, is there a VLAN tag that's actually associated with it. So we'll go across the switch will read it, we'll say, hey, what VLAN is this coming from? It will strip off that VLAN tag to read it, and then it will place the VLAN tag again on it as it goes across a new trunk link. So every time it enters a switch, it strips off the VLAN tag, reads where it's supposed to go, adds the VLAN tag back onto it, and then forwards it to the proper destination. And then when it makes it to the router completely removes the layer 2 header and then forwards it in and out off of the proper areas. And then getting into it again, when we talk about, say, like encapsulation, when we're specifying our .1q encapsulation, that's the method of how we're encapsulating or adding, how we're going to be adding the VLAN tag onto our frame. So that's a lot to kind of take in. Some of that should be review in terms of how traffic's kind of passed back and forth, hopefully. If you do have questions on that, though, let me know. So let's go ahead and kind of get started now that we've kind of gone over a little bit the basics. So I'm going to save this section that I just circled in green for when we get into Etherchannel here. So what I'm going to work on here is VLAN 30 and VLAN 40. Now, backing up just a little bit, one of the reasons I went over that entire process is because I used VLAN 10 and 20 all in this green section. I could have used VLAN 10 and 20 down in this bottom section for PC3 and PC5 here, and there would have been no conflict because, again, like I just stated for that little spiel, a VLAN tag cannot go any further than up to a layer 3 device, and after that, VLAN tags do not matter, and they will not show up, and they will not be known by any other device. So I can reuse VLANs if they're completely separated from a different network. Now, it's not really a great idea to do so because it can obviously get complicated, and same thing, you can kind of start getting you can start confusing yourself as well. So I typically, in this case, I'm keeping it as just 10, 20, 30, and 40 as our VLANs. So looking at our VLANs here, we're going to start on our switch 2, right above PC3 here. And we're going to go into our configuration. And the first thing that we always want to do when we're working with VLANs is we want to create our VLANs and then turn them on, actually get them working. So we're going to say VLAN 10, int VLAN 10. And you can see it changes to state up. And then we say, actually I don't need to use VLAN 10, sorry. I got into autopilot there. So we're going to get rid of VLAN 10, so we're going to say no VLAN 10, and I'll delete it. We only need VLAN 30 and VLAN 40, and then we're also going to create our native VLAN for VLAN 99. So that'll create our VLANs. You can see that they're in an up state now. We're going to do the same thing over on our switch 4 as well, but with a slight kind of change here. So you'll notice on our links that are kind of set up, the only VLAN that will ever be kind of touching or kind of passing information across from switch 4, or the only VLAN that it will ever see traffic from, is VLAN 40. So VLAN 30 will never, it's not associated with that network in any way, shape, and form. So if I wanted to, the only VLAN I need to create and kind of allow across our upcoming trunk link is just VLAN 40, and then I'd also create our native of 99. But VLAN 30 is not required for this network to function. Now, I would still create it, and I would still allow it over the trunk link, because in the likelihood that you are going to be expanding this network, if this is, say, like our business network, we would probably want to make sure that we have things prepared. So if I needed to add, say, like a PC off of here and it needed to be associated with VLAN 30, I wouldn't have to go back through and be like, hey, why is nothing working? And then try and troubleshoot and go, oh, I need to allow VLAN 30 across my trunk link. So we created, so we're going to go ahead and do the same thing then. So we'll go into conft, we'll say VLAN 30, VLAN 40, and VLAN 99, and we'll get them all set up as well. Oops. There we go. And all of our VLANs are up and running. So because I'm already over on this switch, we'll just go ahead and work on this. The area that I'm going to start with is we look at our access ports. And so the thing to know about access ports and trunk ports is access ports always go towards end devices. So they only ever go towards PCs or servers, because you're telling that device what it's supposed to, what VLAN it's accessing, what VLAN it belongs to. So we never use access ports going between intermediary devices, so switch to switch or switch to router. If you're using VLANs, they will never be access ports. But if they're going down, but they will always be access ports going towards PCs or servers. Trunk links will always be the links going between intermediary devices, so switch to switch or switch to router. That's where we're going to see our trunk links, and that's basically what allows multiple VLANs to use a single dedicated link between our devices. So we're going to start by setting up our access port. So we're going to go into int FA02, and we're going to say switch port mode access, and that puts it into an access state. If you're curious what modes we have 3 modes. We have access, dynamic, and trunk. By default, it's in the dynamic state, and so that's why everything has kind of worked. What dynamic will do is it will automatically try and just determine what the best port state should be, and typically it will always default to being access between the two sides. So as long as we're not using VLANs, that's why everything has worked all the way up until this time without having to do or change these modes. But typically, if we're ever working with VLANs, we never want to use dynamic. We always want to be the ones that determine what state that port is going to be. So we set it to access, and we say then we assign it to what VLAN it's going to be accessing. So we say switch port access VLAN 40. And you can see that the port now goes to an up and up state. So it originally just changes to an up, but then once I actually assign it to a interface that's currently up, that state goes to an up state. So it goes to an up and up state. So it means everything should be working. So the next thing that we'll do is we'll go into our FA01, and we're going to create our trunk, assign it to a trunk link. FA01 is the port going over to switch 2 here. So we'll say switch port mode trunk. So you have to tell it what mode to be in first before you can configure the trunk side of things. And then we're going to tell it what's allowed to go across the trunk link. We'll say switch port trunk allowed, VLAN 30 and 40. We don't need to allow the native because we're going to specify what the native is here in the next command. So you only need to specify what VLANs are allowed to go across that aren't the native VLAN. And again, I don't have to specify VLAN 10 and 20 here because they exist on a completely different LAN than where I am, and they'll have to pass through 2 layer 3 devices, so I will never see those VLANs ever, and they're not going to be and I will never see those VLAN tags, so no need to allow them across. And again, like I mentioned, I can just allow VLAN 40 across this single trunk link because only VLAN 40 exists on this side. If VLAN 30 existed as well, I would have to allow both 30 and 40, but because only VLAN 40 exists, I could get away with only doing that. However, remember, I'm going to do 30, 40. Now, the next command we're going to say is switch port trunk native VLAN and assign VLAN 99 as our native. Now, the thing to note here is as soon as I do that, you can start to see that I'm going to start getting error messages saying that there's a native VLAN mismatch. Now, as soon as it does this, it's going to put our port into a blocking state so that no traffic will be allowed to go back and forth between switch 2 and switch 4 here until I fix this mismatch. The default native VLAN is 1. So by switching it to 99, it creates an inconsistency between the two sides. So switch 2, what's nice about this error is that it is actually very descriptive and tells you exactly what the problem is. It says that it's a native VLAN mismatch. It tells you on your FA01 port, you've set it to VLAN 99, and on the opposite side, on FA03, its native is set to 1. And this error will continue to pop up constantly. It's kind of annoying. You can see it just popped up again for me. And it will do it on both sides. So you can start seeing that that error is coming up on both sides as well. What I recommend doing is that on whichever side you've configured first, in FA01, just shut down the port temporarily while you fix and configure the other side. And then once you do that, then you can bring that port back up. And that way you don't have to worry about interruptions from that error message while you finish configuring things. So we're going to go through this again. We've set up our interfaces or our VLANs, so we'll go into our FA02. We'll do the same thing. We'll say switch port mode access, switch port access VLAN 30, and we'll go into our FA03 and we'll say switch port mode trunk, switch port trunk allowed VLAN 30 and 40, switch port trunk native VLAN 99. And now there's one other command that we want to do as well, which is the switch port no negotiate command, and I need to do that over on this side as well. And what this command does is it will stop both switches from trying to do the dynamic auto mode or trying to auto negotiate which protocol they should actually be in or how to basically trunk between the two sides. So it will ignore any requests to trunk unless both sides are set to mode trunk. And this is again kind of just a good security feature and process that we want to set up. So if we look at all our full configs, we have the mode that we put it in, switch port mode trunk, what's allowed, VLAN 30 and 40, what our native VLAN is, which is 99, and switch port no negotiate to ensure that we don't have any auto configuration occurring between the two switches. And then on our other VLAN going down, we have it to switch port mode and access, and we have it assigned to PC5, which is VLAN 40. So that's all we need. If we look at the other side over here as well, we should see that our configs for the port going down to the PC and our trunk link going across should be all fine. So that's all good. So we're going to go ahead and back over on switch 4, say no shutdown, to bring that line back up. And we shouldn't have any more inconsistencies between the two sides. So that's a good thing. So now the next thing that we're going to do is configure our trunk link going up to FAO1 up to router 2 there. So we're going to do the same thing. We're going to say int FA01, and we're going to do switch port mode trunk, and we're going to specify what's allowed. Switch port trunk allowed VLAN 30 and 40, and what our native is. And then our no negotiate command as well. And if we look at our running configuration, we can see that our FAO1, our FAO3, and our FAO2 are all good to go. So that's everything for kind of our switches. So now we're going to move over to our router here, our router 2. And this is what's configuring as known as router on a stick. So we're going to be configuring router 2 here to essentially be the default gateway for both PC3 and PC5. So we'll go into conft, we'll go into int g02, and what we have to do is, because we have two VLANs here, and we only have one single interface, we have to create what's known as sub-interfaces, basically virtual interfaces that are reliant on the current port state of G02. So what I mean by that is, while this port is turned off, I can't create any sub-interfaces. So we have to turn the port on. So we say no shut. Now, whenever we're using sub-interfaces, that is the only command we ever put on the physical interface, which is turn the port on. After that, no touchy. Don't touch that interface at all. Everything else that we're going to be doing is going to be created on our sub-interfaces. So we'll go into int g02, and then we put a period, and then I'm going to put a 30 there, and that will create a sub-interface called g02.30. And now I treat it just like a normal interface, except for one extra thing, which is, because it knows it's a sub-interface, it knows that it has to have a specific method of encapsulation. So it has to be associated with a specific VLAN. So we're going to say encapsulation.1q, and then the VLAN that we're assigning to this sub-interface. Now, the number that I put, the period and then 30 there, it could have been whatever number I wanted. It could have been .1, it could have been .12, it could have been .52. It doesn't matter. This number doesn't assign it to a VLAN, but it's good to match the VLAN that you're going to be using to the sub-interface that you're using, just for general documentation purposes and making sure that you understand what you're doing between those two things. So we say encapsulation.1q30. And then after that, we assign an IP address to it. So we say IP add 192.168.30.1. And that's all we have to do. That's it. So we'll go in and we'll set up our other sub-interface. So we'll call it 2.40. We'll do the same thing, encapsulation.q, and we'll assign it to VLAN 40 with the 40. And then we'll set the IP address to 40.1. Okay, so if all things are working now, over on my PCs, I've already set up IP addresses. I should be able to ping over to 192.168.40.10. And the first ping will fail because of ARP being built, but then we can see that we're getting replies. So our all of our configuration is working, and our inter VLAN routing is working for all of that. So, yay! So I'm going to pause for a sec, and I'm going to go ahead and finish configuring just a couple of the sections of this network, mostly just going through and assigning the access ports and trunk links on certain areas, and then I'm going to demo, come back and show you the demo for Etherchannel here. Okay, so I've gone ahead and just finished kind of configuring some of the switches, getting the rest of the light screen. Only thing I haven't configured is our Etherchannel link and our trunk link going down between our two switches off in this green circle over here. So switch 0 and switch 1 are the only two areas I haven't configured. Now, the one thing I wanted to point out just really quickly, in case people are unaware, the symbol for Etherchannel, if you're ever looking at it on a topology, is when you see the two lines and you see a circle that is overlapping between the two, that is the symbol that defines that you are configuring Etherchannel between those links. So just keep that in mind anytime you see this little circle across those cables. That means that you're doing Etherchannel, or that there is an Etherchannel connection or configuration between those areas. So let's go over our Etherchannel as well. So getting into it, we have our two kind of sides. Like I said, I've just done some very quick configuration. So what we want to do first is we want to note which interfaces we are actually using to actually make our configuration between these two areas. So we're using on this part FAO2 and FAO4, and then we're also and then on the other side we're using FAO1 and FAO4. Now, I didn't really cable this very well, kind of thinking about it, but it kind of helps to highlight, okay, well, what do we have to do if we're kind of setting up these interfaces? So if I wanted to, say, apply a range, if I wanted to configure multiple interfaces to here, I could go in and I could say int range FA02, and then I can put should be able to put a comma and say FA04. And what that will do is it will put me into configuring both FA02 and FA04 at the exact same time. Now, the other thing that I could do as well, like let's say that I was configuring my two ports for FA01 and FA02, not 2 and 4, I could still use the int range command, and I could say FA01 space dash 2, and that would allow me to configure FAO1 through FAO2. So the comma says and, it's basically the delimitation marker for the and, or the hyphen there is the delimitation, is the marker for through. So 1 through 2 I'm configuring, or 2 and 4. So in this case I want to configure 2 and 4, so we'll go back to our int range FAO2, FAO4. Now, the first thing to always do when you're configuring Etherchannel is you don't want to have configs or try and be configuring things while one or both sides are turned on, because both sides need to match configuration in order for an Etherchannel to actually form. So the long and short of it is, whatever you do on one side must be the exact same on the opposite side for Etherchannel to form. So if one side is configured but the other side isn't, Etherchannel can potentially break. So an easy way to kind of ensure that, you know, we're going to try and make sure that our ports will join Etherchannel correctly is to start with at least one side in a shutdown state. So I'm turning off FAO2 and FAO4 up on this top switch, and then once I've got both sides configured, then I'll come back into the FAO2, FAO4 and turn those ports back on. So first thing to kind of do is we're going to create a port channel between these two interfaces. Now again, besides shutting these ports down and putting them into a port channel or a channel group, these are the only configs that actually go on these interfaces. This is very important to know, because if you place your configs, or say like the trunk configuration on these configs, it will actually break Etherchannel for you. So it's very important to know what steps you need to use when you're kind of going through and setting these up. Now, what we're going to do is we're going to say channel-group, and our number also has to match between the sides as well. So we have to say, so if I'm picking channel group 1, that means on the opposite side, I also have to pick channel group 1 as well. So we're going to say channel group 1, we're going to say mode, and then if you're not sure what to use, we have a couple different options of what we can set up. Etherchannel has two methods. We have PAGP and we have LACP. At this point in time during this demo, I'm not going to get into the different methods of or the differences between the two, but right now what we're going to do in this demo is we're going to use PAGP. So we're going to set our channel group to let's set it to auto, or sorry, desirable is what we want. Not auto. We don't want to use auto. We want desirable in this case. So we're going to set it to desirable. You'll see that creates the port channel group. And then what we're going to do next is we're going to go into that actual channel group. So we're going to say int port-channel and the port channel number that you created just there, so port channel 1. Now, in this area, this is where we're going to be doing all of our actual configuration between these two sides. So everything that all of our trunk link configuration, assigning what's allowed to go across the trunk, all of this goes here. And then this configuration will get applied to FAO2 and FAO4. So we'll say int, switch port mode trunk, switch port trunk allowed VLAN 10, 20, and switch port trunk native VLAN 99, and switch port no negotiate. So now that I've done that, everything's all configured, and if we look at our running configuration, we can see that I have my port channel group, and you can see all the configs that I just applied to my interfaces, which is FAO2 and FAO4. All of these configs are now applied to FAO2 and FAO4. I already set up FAO1 because that's the port that's going over to the router, which is why that's currently in trunk state as well. But you can see FAO2 and FAO4 are still shut down as well. So now that I've done that, we're going to do the same on our bottom switch, our switch 1 here that's connected to PC0 and PC1. And we're going to go in and we're going to say, do the exact same thing. We're going to say int range, and then our two ports that we're using, so FA01, and because they're not directly next to each other, I'm using 1 and 4, we use the comma, so we say 1 and 4, and then we don't need to shut these down because the opposite side is already shut down, so they're already in a down state. So we say same thing, channel group 1, mode desirable, and then we go into our port channel and we do our same configuration. So we say switch port mode trunk, switch port trunk allowed VLAN 10 and 20, what our native is, and our no negotiate. And my puppy who's joining us is having some nice dreams, if you heard the little whining there. So now that we've got that all set up, we'll look at our configuration just to verify. FAO1 and FAO4 look configured, so we should be good to go. So we'll go back to our other switch here, and we'll go into our int range again for FA02 and FA04, and we'll say no shutdown. And we should see that our port state changes to up, and if we fast forward a little bit, we should see that all of our lights between this are all green. Now, this is a very good sign, because if one of these was amber, it would mean that spanning tree protocol is blocking one of our ports and Etherchannel is not functioning as intended. So that's something to kind of keep in mind, is if you see all green lights, it's usually a good thing when you're looking at this. Not always, but typically it is a good indication that Etherchannel is going to work. Now we can also type in the show Etherchannel command, and we can see what information is currently being used, and we can also say, look at, say, the summary, so we can see what ports are in it, and we can see that things are in a port channel, things are currently in use, looks like they're functioning, so should be all good. So if I go over to my PC1 over here, I should, now that Etherchannel is functioning and I have everything else configured, be able to ping over to VLAN 20 there. So if I ping over to 192.168.20.10, first one should fail, and then we see reply, reply, reply. So traffic is working, going over across. So we have inner VLAN working across our Etherchannel. Awesome. So that brings us to the next part, which is getting into OSPF. So everything works in our links over here. That's a point-to-point link, so, or kind of, it's just a PC going to a router, so there was no configuration on that switch. So everything works on this. However, there's no interconnectivity between networks. All point-to-point networks or connectivity exists within LAN, but if PC10 or PC0 here on VLAN 10 tried to get over to PC3 on VLAN 30, it would fail. So we need to fix that. Now, the primary way that we've done this so far is static routing, which is you have to tell the router every single network that it is not directly connected to, and then how to get there. Now, in this type of topology, that's where things can start getting a little confusing. So what we're going to do is we're going to use dynamic routing instead, in order to let the routers tell each other about what networks they already know, and then they'll learn about the routes that the other routers know. So they'll share routing information. They share routing tables between this. There's a lot more that actually happens in how OSPF actually functions, but for the time being, we're just going to go over the configuration. In the later video, I'll show you and do a little bit more of a talk and a demo about OSPF. I did post a video for you guys, and also the PowerPoints that I will be covering likely as well. So just keep that in mind. Okay, so on our router, how we're going to go through our routing, we go into our global configuration, and the router I'm on right now is this top left-hand router, router 0. And we're going to go in and we're going to say router OSPF, and then we need to pick a process ID number. Now, this number I can pick anywhere from 1 to 65,535. This number is not that important grand scheme of things. I can pick any number that I want. It doesn't need to match anything. It's just a local number for this single device. So you don't need to worry too much about what number you pick. Now, I just keep it easy for myself. I just pick like 10. But the number doesn't matter. So after that, if we look at our configuration, the difference between dynamic routing and static routing is, like I stated, is in static routing you have to tell the router every network that it doesn't already know, so everything it's not physically touching. In dynamic routing, you tell the router everything it already knows. So you tell it, hey, what networks are you physically touching? Advertise that you know about these networks. So we use the network command, and then we specify the networks that we are physically touching. So router 0 here is physically touching 4 networks. It's touching the 10.0 network, the 20.0 network, the 10.0.0/30 network, and the .8/30 network. So we need to tell it that all of those networks exist. So we're going to say 192.168.10.0. And now the thing that we need to note here too is that OSPF uses what's known as a wildcard as well, instead of the mask. All a wildcard is it's just the inverse of what a normal mask is. So if I was telling it about 192.168.10.0, a normal mask would be 255.255.255.0. Well, the inverse of that is 0.0.0.255. So I'm saying there's nothing left in the first 3 octets. They're all zeros, but I have 255 left in the final octet, the 4th octet. And then we also need to assign it to what's known as an area. In this case, for right now, the only thing you need to know is that when we're specifying an area, we're always going to be assigning it to area 0. Besides that, you don't need to worry about any other areas for the time being. We're only going to be using area 0. So the other network we need to tell it that we know about is the 20.0, and then we are also touching 2 other networks, which is the 10.0.0.0, and remember the mask for a/30 is a 252. So the wildcard for this is the inverse, or basically what's left, the remainder of what's in a mask, and all that remains in a /30 is 3. Because we have 252, our maximum is 255, so we have 3 remaining. And we assign it to area 0. And then we also know about network 8, the .8 as well. Okay. That's it for the most part in terms of telling it how to actually send traffic out. Now there's one extra thing that we want to do, which is basically to say, hey, I don't want to send routing information out towards devices that are not going to be participating in OSPF, i.e. I don't need to send routing information out any of these devices over here to the PCs or the switches. Routing information is all layer 3 information. Switches and PCs don't care about that info. They don't know what OSPF is, and they don't care what OSPF is. So in order to stop that traffic from being sent out, we use what's known as a passive interface command. So we say passive int, and then we basically just state what interface we don't want that traffic to be sent out of, and I don't want traffic to be sent out of my G02 interface, so I say passive int G02. And that'll stop all traffic from being sent out of that physical interface. So that's it. So if we look at our actual configuration, and we look at our OSPF, this is our configs. This is all we have. I can do more. There is more things I can do to configure OSPF, but in a nutshell, this is all you have to do, which is tell it the networks that you're physically touching. And this tells the router to advertise to other devices that it's physically touching, hey, I know these networks. If you don't know them, add them to your routing table, and if you ever need to get to them, you can send traffic to me because I'm physically touching these networks. I know how to get to them. So if we look at our other configs, we'll go through this as well. Oops, enable first. And we'll do our same thing. So we'll say router OSPF. I'm just going to call it 10. Again, the number doesn't have to match. I could do 13, I could do 12, heck, I'll do 12. It doesn't matter. It's just a process ID number that's only locally significant to that device. And so we'll do the same thing. We say the networks that we're touching. So it's touching the 192.168.50.0, and we use the wildcard, and we assign it to area 0. And then it's also touching the 10.0.0.0 network, the wildcard for /3, and it's also touching the 10.0.0.4 network as well. And then we're also going to put a passive interface on G02. And one of the things you can see is as soon as I got that configured and things were starting to advertise, once they have a shared network between the two, since I already configured this device over here, we can see that I have an adjacency form between these two sides. So that's kind of the nice thing of how I've kind of configured that. So then the final device that we do, exact same thing. We'll go into our router OSPF, and I'll use 10 again over here. It doesn't matter. And again, we do the same thing. We tell it the networks that we know. We know the 30 network, we know the 40 network, and we also know the 10.0.0.4 network, and we also know about the 10.0.0.8 network as well. And then same thing, we're putting a passive interface on G02. We can see traffic is now loading. I have neighbor adjacencies, so adjacencies have formed. So if I look at my routing table, show IP routes, we can see that I have what's known as O routes, or OSPF routes now exist in my routing table. So I now know about the 10.0.0/30. I also now know about the 10 and 20 networks, and I also know about the 50 network. So my PC down here on PC3 should now be able to ping all the way over to VLAN 10 off on the left over there at 10.10, and I can. I should be able to ping to 20.10, and I can. And I should be able to ping over to the 50.10. And that one will fail the first time, but then we see I can indeed ping to it. So that's a lot of information I just kind of covered there. So again, going over VLANs, Etherchannel, OSPF. If you have questions on this, please feel free to send me a message. There's a lot to go over and a lot to practice there. Yeah. Hopefully this was helpful. Thanks.